So my plan is to take you guys through a bit of a scenario, something that we can build on through the next few sets of lessons and give you some idea for your own. So I'm going to use stock characters just to save time, so that way you can also follow me and we don't need to do any of the Google image searches. So what I'm going to do is I'm going to create a very simple new scenario, and I'm just going to show you how you can put a joystick in there. So I'm going to call this Ant World. I don't know why I picked the ant, but one of the built-in characters is an ant, and that's what I'm going to use as my main character. And I'll pick a background first. Again, this is not super critical to demonstrate to you. You can pick your own more interesting background if you like, but oops, there it is. And I don't even know why I was so particular here, but I guess the ant, I think there's a sand in here. I don't think ants are actually, well, I guess they do walk on sand, but anyway, and I'll call this the, maybe this is the yard where the ants live. So once you compile this, you're going to get the world should show up here. And remember, the way that this works is right now it's 600 by 400 pixels, and each cell is a 1 by 1 pixel. So I'm going to go in and get my actor here, and I'm going to make this the ant. So here's my main character. If this is you doing Pac-Man or Donkey Kong or whatever it is, this is your main character too. So I'm going to first hook up the joystick and show you how it works. So there's my ant actor. And we didn't talk about coding last day. All we talked about was how to build and add your characters and things. So in the grid world, sorry, in the Greenfoot, I'm saying grid world because it's a very similar one from the advanced placement course. But instead of having a main method, what happens is every character in the game has an act method, and every time a sequence of the game runs, everybody gets called act. So basically, every time the game advances, everybody has a turn to act accordingly. So this is where all of your code goes to tell the actor what it's supposed to do. So I'm going to program the keyboard into the ant, and the way I'm going to do that is I'm going to first show you how to track it down, and then I'll code it in Java. So the stock classes have documentation, same as what we've already been looking through. It's the same format, the Java documentation. And it looks like this. If you're not interested in seeing this one class, you can go up here to the one that says package. And when you click package, this is the entire Greenfoot API. So this is what comes with Greenfoot. Everything else we either have to borrow from greenfoot.org or build ourselves. So the actor, the way actors behave, and the way the world behaves is here as well. Now, the utility class we're going to use for the keyboard is this Greenfoot, and it says here to control the simulation and interact. That's kind of gives you a clue. That's where you want to go, is the Greenfoot class. So this is just like when we practice basic objects like math string or different graphics. It'll tell you about how to build it, how to use it. Here's all the things here. Getting the mic level, getting the mouse info, a random number, is a key down, all this kind of stuff. So what I'm going to do instead is the one I'm going to go to is the is key down. Okay. And it tells me if the current key is being pressed or not. So what it takes on is a string, which is the name of the key. So I'll click on this and find out the name of the key, and it returns true if the key is down, false otherwise. So it's basically a yes or no function. There's a similar method. You can look into it if you want this for your keyboard. Whoops. It's just called get key. It's the most recently pressed key. So if you want to know what was the last key touched, this one will tell you what key. And in this documentation, it also tells you here's how the keys are named if you want to get them. So if you're having two characters with keyboards, you can use one side of the keyboard for a joystick and then the other side. So I'm just going to use the standard up, down, left, right sort of keyboard cursor keys. And that's what I'm going to program into here. So here's how an if-else block works in Java. The simplest way to do it is say if is key down, and I'm going to look for the up key. What do you think I should make my character do if the up key is pressed? The first thing we should think about is when characters move, they usually face the direction that they're moving, right? So that's the first thing I want to do is make the character turn and face up. The second thing I want to do then is actually move the character. So here's the Java code that accomplishes this. In Greentfoot, the directions go like this. I'll just show you with Microsoft Word here. So here's the axes in Greentfoot. Same as you use in math class. But what I have is a little different than what you've been taught in math class. Over here, this corner is 0 degrees. Right there. I'll make this smaller here. It's a little... Where that arrow points right now, that is 0 degrees. And the rest of the degrees go like this. The next rotation down here, that is at 90 degrees, meaning it's rotated by 90 degrees. The next one over here is 180. And finally, you're over at 270 if you're at the top. So the reason you need to know about this is you need to know how to face your character. You need to know what degrees you're pointing towards. You're not limited to 0 to 360. If you use an angle like 540, it knows to do a full rotation and then a little bit more. So 540 will end up over here at the 180 degrees. That's okay too. You don't have to worry about limiting it. But I can use this set direction method, and to face up is 270 degrees. And to move an actor, that's what I say is move 1. Oops. Somehow there's an extra symbol there. Oh, so my apologies. I guess I got a little excited, but Greentfoot is who I have to ask if the key is down. So I just put is key down. I forgot to use the utility class. Same way you use the math class, you ask it if the key is down. And now that I think about this, I actually think it's set rotation. Let me just, we'll check. So now I'm okay. And what I will do is show you that now my ant can move up. When I put it in the world, there's my ant. And if I hit the up key, see it turned up, and it's now moving up. No other key on this keyboard does anything. Only the up key works. So that's why a decision is something we need to learn to use in programming, is this code is only executed if the condition above is true. So those braces tell Java this code can only be executed if this condition is true. It will skip those braces if the condition is false. Okay. So how do we hook up the rest of the keyboard? Well, you have to be careful when you copy and paste, because sometimes you copy and paste errors over and over again. But I'm basically doing the same thing. Let's say I want to go to the left. If I'm going to the left, according to what we were talking about here, left is 180 degrees. So I can fill this out as 180 and move one cell. Okay. So I can continue to do this for each of the directions on the keypad. Down, again, if you need to refer to it, it's 90 degrees. So I'll set the direction of my character to 90 and move. And then finally, I just need to do right, which is 0. So now, if I actually move the ant, I'll put one in the world, and I will run my game. I have an ant that can do all kinds of directions and movements. Now, one thing you might want to notice here is I can actually get a diagonal by holding both keys, because it's checking which ones are down, and it checks and says, yes, both keys are down. So just so you're thinking about how a decision works, any of these 4 things could be true. So Java may execute any of those 4 items. But alternatively, what I can do is say to Java, well, I only want the option of doing one of these things. And the way you group them together is with an else if statement. So this means if it's true, then you will execute the code. Otherwise, check this condition. So each time I connect it with an else, I'm basically telling the character it can only do one of those, because the minute one of them is true, then it stops looking for another. Again, in English, it's like you're saying otherwise. It's like, if it's raining, we'll go to my house. Otherwise, we'll go to the park. You typically wouldn't do both, go to the park and your house, because you've given an exclusive choice, one or the other. So the difference now when I run this program is that it'll only execute one of those key commands, which means there's no more diagonals. Because a diagonal is like up and right at the same time. And now I only get one of those keys winning out. I can't go diagonally anymore. If you want to know which key wins, you have to look at what order you ask Java to evaluate it. So if I'm holding the up key and I'm holding the right key, that means I would like it to go like this, up and to the right. So the way this mouse is moving right now, up and to the right. The problem is, Java will find that this is true, and it will not look any further to see if any other keys need to be connected. So there are times when this is useful, and there are times when you don't want that kind of branch, and you just want it to function like this. So depending on the abilities of your character, you will use an if statement or an else if. And the default of all those is you can use a final block called an else, which means if nothing else was executed, if nothing else was true, then maybe I'll just stop the game. So I can say Greenfoot.stop. So what you'll notice is when I run the game this time, every time I hit run, it stops because the key's not being pushed on the joystick. Now I'm going to move him to the right, and I'm going to run the game. Oh, I guess Java can't handle that one. It's not able to do that. So why don't I instead, just so you can see what happens, I'll say move 30. So if I don't give it the joystick, it's going to move 30 cells. So watch what happens to the ant now. Whoa. So it's nice and slow when I'm using the joystick, but as soon as I let go of the joystick, he takes off because I wasn't doing any of those things I asked Java to do. Okay? So that also is to help you see that that's what the move method does. That controls the speed. So move 1 means move 1 cell, and in our world that's 1 pixel. Move 30 means move 30 cells, which is 30 pixels. So it's 30 times faster. Okay, so this is what I would like you to be able to do, is connect some interaction with your character. And I would like you to do that with if-else statements and learn about how to use decisions in Java. There's one final thing about this beginning stages of Greenfoot that may be peculiar to you. And this is consistent of every graphics system on a computer that I know of, which is this direction here. When I'm looking at the pixels, this is what the pixels are going to do for X, which is not really a surprise. They're getting bigger as I move to the right. However, as I move down, they actually get bigger for Y. So if you're in Greenfoot and you want to know what position am I at here, you're actually 3 over and 3 down, but those get treated as positives. So normally when you're doing your math, the y-axis is positive if I move up. That's the only flip you have to make now when you do computer graphics, is that down is actually positive for y. Everything else is consistent, so all the math that you normally do will still work, but you just have to remember that when you are moving visually lower, you are increasing the y coordinate. So down here, this is top corner of your screen is 0, 0. Where the mouse is right now, this is pixel 0, 0. And the pixels increase to the right, and they increase as I get lower. So this would be the largest pixels in the bottom right corner, the farthest to the right, and the farthest down. Okay, so that's all I want to say about it today. So I want you to have some fun putting your joysticks in, and you can check the video out again if you want to refer to some of the stuff we did.